That should be positive, right?
Well, no, if A equals 1, I mean, if Y equals 1 when T equals 1, that means we're at this point. Right? Oh, sorry. That's, yeah, never mind, that's right.
Yeah.
Out here. Okay. So this means that we start here. So,
Mr. Smith, I have a question.
yeah, but let me finish writing this so I don't get any more confused than I seem to be already. Yeah, go ahead.
Okay, the slope of this y versus t graph, it's a parabola, right? Depending on the t variable.
The slope isn't a parabola, the graph is a parabola.
So your slope at any y variable, y point, should be the same, right? So if it's like, if it's yt 1, 1, 2, 1, 3, 1, your slope at those points should they all be the same?
Let's clarify that, okay? Got this direction field, okay? Let's accept this direction field. So let me just rewrite it. We got this, this, and this. We've got this, this, and this. We've got this, this, and this. It's not particularly accurate, but there it is, okay? Now, I can start at any point in this direction field and start generating a curve, right? So, starting here, what should the slope be? Well, somewhere between, yeah, you got these 4 slopes around here, kind of an average of those 4, more or less. The trend is going to be probably something like this. Okay? You know, that follows the flow of the direction field. It's the trend of your solution. Now, if I was to start here, I would start with a lower slope and get something like this, right? Now, as I go back over this way, because I can always have a negative delta t, right? Okay? What's going to happen? Well, another thing's going to happen is, as you approach the y-axis, 2 over t blows up on you. It's going to approach infinity, right? So you're going to get over here, you know, you're going to kind of have a vertical barrier. You're going to have an asymptote. So this thing's going to have to approach an asymptote, right? And out here, as t gets large, slopes are going to approach 0, right? So you're getting something like this, which looks a lot like a natural log. Okay? That makes sense? That's what it looks like to me. And you see how we could easily get a natural log. But, you know, I don't see a whole lot wrong with our solution. Okay? And, you know, of course, your y equals at squared, that family of functions just looks like this, depending on your value of a. Okay? These are y equals at squared curves. And the slope field that goes with these curves is what? Well, you can just draw it. Okay, here's a slope, 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 here's a slope. Okay? also, this is perfectly well defined when t equals 0. Okay? So somebody did something really bonehead here. And since we all kind of did the same thing, well, I don't want to accuse you because you have an excuse. I don't. So what in the world is going on here? We need to go back to our solution and make sure we don't have a bug, because there's something terribly wrong here. However, in the process of noticing that there's something terribly wrong, and I didn't do that intentionally. Yeah, I did that intentionally just because there's a lesson in it, right? Okay? We have to check things for consistency. And there's a glaring inconsistency that arises as soon as we draw this direction field. And then we investigate, well, you know, if we extended this, the curves are going to look like that. They look a whole lot like natural logs, but we got that 2 in there. What are we going to do about that? Because it works. And this function works when substituted into the equation, right? So something is bizarre here. There are all kinds of questions that arise in this extremely simple example that we should have been done with half an hour ago. But we're learning stuff, okay? Because unconsciously, I must have planned it that way. Okay, well, let's see where we are and see how we can fix this.